Hi, this is Sleeper. Welcome back to my channel. We are continuing the Getting Started module from Hack the Box Academy. If you need access to Hack the Box Academy, you can sign up with the link below. Keep in mind, Hack the Box Academy and the main Hack the Box website are two separate accounts with different plans available. I recommend the Silver Annual Plan as it gives you access to all the job role paths, all the modules up to Tier 2, and an exam voucher, good for any of the Hack the Box certifications. So let's go ahead and continue. Basic tools. Tools such as SSH, Netcat, tmux, and Vim are essential and are used daily by most information security professionals. Although these tools are not intended to be penetration testing tools, they are critical to the penetration testing process, so we must master them. Using SSH. Secure Shell, SSH, is a network protocol that runs on port 22 by default and provides users, such as system administrators, a secure way to access a computer remotely. SSH can be configured with password authentication or passwordless using public key authentication, using an SSH public and private key pair. SSH can be used to remotely access systems on the same network over the internet, facilitate connections to resources in other networks, using port forwarding, proxying, and download files to and from remote systems. SSH uses a client-server model, connecting a user running an SSH client application such as OpenSSH to an SSH server. While attacking a box or during a real-world assessment, we often obtain clear text credentials or an SSH private key that can be leveraged to connect directly to a system via SSH. An SSH connection is typically much more stable than a reverse shell connection and can often be used as a jump host to enumerate and attack other hosts in the network, transfer tools, set up persistence, etc. If we obtain a set of credentials, we can use SSH to log in remotely to the server by using the username at the remote server IP as follows: SSH bob at 10.10.10.10. It is also possible to read local private keys on a compromised system or add our public key to gain SSH access to a specific user, as we'll discuss in a later section. As we can see, SSH is an excellent tool for securely connecting to a remote machine. It also provides a way for mapping local ports on the remote machine to our local host, which can become handy at times. Using Netcat. Netcat, NCAT, or NC is an excellent network utility for interacting with TCP/UDP ports. It can be used for many things during a pen test. Its primary usage is for connecting to shells, which we'll discuss later in this module. In addition to that, Netcat can be used to connect to any listening port and interact with the service running on that port. For example, SSH is programmed to handle connections over port 22 to send all data and keys. We can connect to TC port 22 with Netcat. So Netcat 10.10.10.10, port 22. As we can see, port 22 sent us its banner, stating that SSH is running on it. This technique is called banner grabbing and can help identify what service is running on that particular port. Netcat comes pre-installed in most Linux distributions. We can also download a copy for Windows machines from this link. There's another Windows alternative to Netcat, coded in PowerShell called PowerCat. Netcat can also be used to transfer files between machines, as we'll discuss later. Another similar network utility is SOCAT, which has a few features that Netcat does not support, like port forwards and connecting to several devices. SOCAT can also be used to upgrade a shell to a fully interactive TTY. We will see a few examples of this in a later section. SOCAT is a very handy utility that should be part of every penetration tester's toolkit. A standalone binary of SOCAT can be transferred to a system after obtaining remote code execution to get a more stable reverse shell connection. Using TMUX. Terminal multiplexers like TMUX or Screen are great utilities for expanding a standard Linux terminal's features, like having multiple windows within one terminal and jumping between them. Let's see some examples of using TMUX, which is the more common of the two. If TMUX is not present on our Linux system, we can install it with the following command: sudo apt install tmux-y. Once we have tmux, we can start it by entering tmux as our command. The default key to input tmux commands prefix is Ctrl+B. In order to open a new window in tmux, we can hit the prefix, Ctrl+B, and then hit C. We see the number of windows at the bottom. We can switch to each window by hitting the prefix and then inputting the window number like 0 or 1. We can also split a window vertically into panes by hitting the prefix and then shift %. We can also split into horizontal panes by hitting the prefix and then shift quote double quotes. We can switch between panes by hitting the prefix and then left or right arrows for horizontal switching, or the up and down arrows for vertical switching. The commands above cover some basic tmux usage. It is a powerful tool and can be used for many things, including logging, which is very important during any technical engagement. This cheat sheet is a very handy reference. Also, this introduction to tmux video by IPSEC is worth your time. Using Vim. Vim is a great text editor that can be used for writing code or editing text files on Linux systems. One of the great benefits of using Vim is that it relies entirely on the keyboard, so you do not have to use the mouse, which, once we get the hold of it, will significantly increase your productivity and efficiency in writing/editing code. We usually find Vim or V installed on compromised Linux systems, so learning how to use it allows us to edit files even on remote systems. Vim also has many other features, like extensions and plugins, which can significantly extend its usage and make for a great code editor. Let's see some of the basics of Vim. To open a file with Vim, we can add the file name after it. So vim /hosts. If we want to create a new file, input the new file name, and Vim will open a new file window with that file. Once we open a file, we are in read-only normal mode, which allows us to navigate and read the file. To edit the file, we hit I to enter insert mode, shown by the --insert at the bottom of Vim. Afterward, we can move the text cursor and edit the file. Once we are finished editing a file, we can hit the escape key to get out of insert mode, back into normal mode. When we are in normal mode, we can use the following keys to perform some useful shortcuts. So X, cut a character, DW, cut a word, double D, cut full line. YW, copy word, YY, copy full line, and P, paste. Tip: we can multiply any command to run multiple times by adding a number before it. For example, for YW would copy 4 words instead of 1, and so on. If we want to save a file or quit Vim, we have to press colon to go into command mode. Once we do, we will see any commands we type at the bottom of the Vim window. There are many commands available to us. The following are some of them. So, :1, go to line number 1. :W, write the file and save. :Q, quit. :Q, exclamation point, quit without saving. And :WQ, write and quit. Vim is a powerful tool and has many other commands and features. This cheat sheet is an excellent resource for further unlocking the power of Vim. So we've got an optional exercise. I went ahead and spawned that. We'll spawn the target. Challenge your understanding of the module content and answer the optional questions below. These are considered supplementary content and are not required to complete the module. You can reveal the answer at any time to check your work. So we've got the IP and the port. Let's grab this. Copy. And it's asking to grab the banner. And as it mentioned with netcat, if we just netcat maybe just that port, we can see what we've got. So we'll open the command line and paste that in. Netcat. And enter. So we've got SSH, so it's running SSH. So we'll copy that and paste that in. There we go. Service scanning. We're ready to take it a step further and start exploring a machine. The first thing we need to do is identify the operating system and any available services that might be running. A service is an application running on a computer that performs some useful function for other users or computers. We call these specialized machines that host these useful services servers instead of workstations, allowing users to interact with and consume these various services. What we're interested in are services that have either been misconfigured or have a vulnerability. Instead of performing the actions expected as part of the service, we are interested to see if we can coerce the service into performing some unintended action that supports our objectives, such as executing a command of our choosing. Computers are assigned an IP address, which allows them to be uniquely identified and accessible on a network. The services running on these computers may be assigned a port number to make the service accessible. As discussed prior, port numbers range from 1 to 65,535, with the range of well-known ports 1 to 1023 being reserved for privileged services. Port O, port 0 is a reserved port on TCP/IP networking and is not used in TCP or UDP messages. If anything attempts to bind to port O, such as a service, it will bind to the next available port above port 1024 because port O is treated as a wildcard port. To access a service remotely, we need to connect using the correct IP address and port number and use a language that the service understands. Manually examining all of the 65,535 ports for any available services would be laborious. And so tools have been created to automate this process and scan the range of ports for us. One of the most commonly used scanning tools is Nmap, or Network Mapper. Nmap. Let us start with the most basic scan. Suppose that we want to perform a basic scan against a target residing at 10.129.42.253. To do this, we should type Nmap and the IP address and hit enter or return. We see that the Nmap scan was completed very quickly. This is because if we don't specify any additional options, Nmap will only scan the 1,000 most common ports by default. The scan output reveals that ports 21, 22, 80, 139, and 445 are available. Under the port heading, it also tells us that these are TCP ports. By default, Nmap will conduct a TCP scan unless specifically requested to perform a UDP scan. The state heading confirms that these ports are open. Sometimes we will see other ports listed that have a different state, such as filtered. This can happen if a firewall is only allowing access to the ports from specific addresses. The service heading tells us the service's name is typically mapped to the specific port number. However, the default scan will not tell us what is listening on that port until we instruct Nmap to interact with the service and attempt to tease out identifying information. It could be another service altogether. As we gain familiarity, we will notice that several ports are commonly associated with Linux or Windows. For example, port 3389 is the default port for remote desktop services and is an excellent indication that the target is a Windows machine. In our current scenario, port 22 SSH being available indicates that the target is running Linux or Unix, but the service can also be configured on Windows. Let us run a more advanced Nmap scan and gather more information about the target device. We can use the -S(C) parameter to specify that Nmap scripts should be used to try and obtain more detailed information. The -S(V) parameter instructs Nmap to perform a version scan. In this scan, Nmap will fingerprint services on the target system and identify the service protocol, application name, and version. The version scan is underpinned by a comprehensive database of over 1,000 service signatures. Finally, the -P- parameter tells Nmap that we want to scan all 65.535 TCP ports. This returns a lot more information. We see that it took a lot longer to scan all of the ports rather than 1,000. The -SC and the -SV options also increase the duration of a scan, as instead of performing a simple TCP handshake, they perform a lot more checks. We notice that this time there is a version heading, which reports the service version and operating system if this is possible to identify. So far, we know that the operating system is Ubuntu Linux. Application versions can also help reveal the target OS version. Take OpenSSH, for example. We see the reported version is OpenSSH 8.2p1 Ubuntu for Ubuntu 0.1. From inspection of other Ubuntu SSH package change logs, we see the release version takes the format 1:7.3p1-1 Ubuntu 0.1. Updating our version to fit this format, we get 1:8 2p1 for Ubuntu 0.1. A quick search for this version online reveals that it is included in the Ubuntu Linux FOSA 20.04. Another quick search reveals that the release date of this OS is April 23rd, 2020. However, it is worth noting that this cross-referencing technique is not entirely reliable, as it is possible to install more recent application packages on an older OS version. The script scan-sc flag causes Nmap to report the server header's HTTP server header page and the page title HTTP title for any web page hosted on the web server. The web page title PHP 7.4.3 PHP info indicates that this is a PHP info file, which is often manually created to confirm that PHP has been successfully installed. The title and PHP info page also reveals the PHP version, which is worth noting if it is vulnerable. Nmap scripts. Specifying -sc will run many useful default scripts against a target, but there are cases when running a specific script is required. For example, in an assessment scope, we may be asked to audit a large Citrix installation. We could use this Nmap script to audit for the severe Citrix NetScaler vulnerability, CVE 2019-19781, while Nmap also has other scripts to audit a Citrix installation. The syntax for running an Nmap script is nmap --script. You have the script name, -p port, and the host. Nmap scripts are a great way to enhance our scans functionality, and inspection of the available options will pay dividends. Check out the Network Enumeration with Nmap module for more detailed study of the Nmap tool. Attacking network services. Banner grabbing. As previously discussed, banner grabbing is a useful technique to fingerprint a service quickly. Often a service will look to identify itself by displaying a banner once a connection is initiated. Nmap will attempt to grab the banners if the syntax nmap-sv --script equals banner target is specified. We can also attempt this manually using netcat. Let's take another example using the NC version of netcat. So like our example or question from the previous section. This reveals the version of VS FTPD on the server is 3.0.3. We can also automate this process using Nmap's powerful scripting engine using that following command. FTP. It is worth gaining familiarity with FTP as it is a standard protocol, and this service can often contain interesting data. A Nmap scan of the default port for FTP21 reveals that VS FTPD 3.0.3 installation that we identified previously. Further, it also reports that anonymous authentication is enabled and that a pub directory is available. Let's connect to the service using the FTP command line utility. So FTP-P and our IP address. Username anonymous, password anonymous. In the above shell, we see that FTP supports common commands such as cd and list, and allow us to download files using the get command. Inspection of the downloaded login.txt reveals credentials that we could use to further our access to the system. SMB. SMB, server message block, is a prevalent protocol on Windows machines that provides many vectors for vertical and lateral movement. Sensitive data, including credentials, can be in a network file shares, and some SMB versions may be vulnerable to RCE exploits such as Eternal Blue. It is crucial to enumerate this sizable potential attack surface carefully. Nmap has many scripts for enumerating SMB, such as smb-os-discovery.nse, which will interact with the SMB service to extract the reported operating system version. So in this case, the host runs a legacy Windows 7 operating system, and we could conduct further enumeration to confirm if it is vulnerable to Eternal Blue. The Metasploit framework has several modules for Eternal Blue that can be used to validate the vulnerability and exploit it, as we will see in an upcoming section. We can run a scan against our target machine for this module section to gather more information from the SMB service. We can ascertain that the host runs a Linux kernel Samba version 4.6.2, and the host name is gscvc scan. Shares. SMB allows users and administrators to share folders and make them accessible remotely by other users. Often these shares have files in them that contain sensitive information, such as passwords. A tool that can enumerate and interact with SMB shares is SMB Client. The "L" flag specifies that we want to retrieve a list of the available shares on the remote host, while "N" suppresses the password prompt. This reveals that the non-default shares share users. Let us attempt to connect as the guest user. The list command resulted in an access denied message indicating that guest access is not permitted. Let us try again using the credentials for the user Bob. Bob, welcome 1. We list, and we successfully gained access to the user shares using credentials and gained access to the interesting file passwords.txt, which can be downloaded with the git command. SNMP. SNMP community strings provide information and statistics about a router or device, helping us gain access to it. The manufacturer default community strings of public and private are often unchanged. In SNMP versions 1 and 2C, access is controlled using a plain text community string, and if we know the name, we can gain access to it. Encryption and authentication were only added in SNMP version 3. Much information can be gained from SNMP. Examination of process parameters might reveal credentials passed on the command line, which might be possible to reuse for other externally accessible services, given the prevalence of password reuse in enterprise environments. Routing information, services bound to additional interfaces, and the version of installed software can also be revealed. A tool such as 161 can be used to brute force the community string names using a direct dictionary file of common community strings, such as the dict.txt file included in the GitHub repo for the tool. And conclusion. Service scanning and enumeration is a vast subject that we will learn more about as we go along. The aspects we have covered here apply to many networks, including hack-the-box machines. And we've got a few questions. We'll go ahead and spawn the target, and we'll read through these first before we go through. Perform a network mapping scan on the target. What is the version of the service from the Nmap scan running on port 8080? In that Nmap scan, identify the non-default port that the telnet service is running on. And lastly, list the SMB shares available on the target host. Connect to the available shares or share as the Bob user. And once connected, access the folder called flag and submit the contents of the flag.txt file. So run an nmap scan, what version is on 8080, what's the non-default port for telnet, and grab the flag from the SMB shares. So let's go ahead and do that. We'll do SV for the service and paste in our IP address. We might need just one more for the full nmap scan. So we'll just go ahead and get that running. And which one was it asking? Port 8080. Here we go. Version number. Didn't get a version number here, so we'll go more aggressive. Let's also do the SC like it mentioned. We could also probably visit the webpage. Tomcat. Okay, so telnet. Most likely this. If we do an aggressive scan, telnet is usually 23, so probably 23. We'll just check it. There we go. What is the version of the service of Tomcat? Let's see if we got it here. Version Zoom out a little bit. Okay. Not seeing a version number, so let's visit it in the browser. 8080. See if there is Tomcat 9. So let's see if it'll just take 9. Tomcat 9. Error. Okay. Let's retrace our steps. Nmap-A 8080. Maybe we'll try that. Or netcat. Let's try it. Netcat, the port. Oops. Okay. Netcat and port 8080. Okay, didn't like that. Let's try what it also has. It was the, where'd it go? -NV. Flag. No, I don't think that's it either. So, Map will attempt to grab the banners like so. We'll try this. If we can get the banner. Kill that. Post this. Jump it here. 10.129.42.254. And we needed the port 8080. That's okay. Further investigate here if we can find a version number. It says 9, but maybe we need to just try a variation like Tomcat 9. Sometimes it does that. Okay. We can skip ahead if this doesn't work in a moment. And let's check the cheat sheet real quick. Vim scanning. Okay. So let's just go ahead and list our shares first. If anything here pops up. It's not really giving an answer. What is the version? Trying 9 again. Okay. So we'll list the shares. Skip to the third question. In 10.129.42.254. Okay. So we've got users. So it said let's go ahead and connect to users with Bob. So not listing, but trying to connect. So access denied. We need the user, Bob. Let me get the right flag in here. Dash capital U. Login failure. Maybe try dash dash user. Login failed. Okay. So check the cheat sheet. Too far. Where are we? SMB client. Connect. So we don't need the N. Because the N, I remember now, the N cuts out the login attempt. So, and as capital welcome 1. Okay. And we see the flag directory, and we list it, and we'll get the flag. Okay. Exit cat flag.txt, and there we go. Copy that, paste that in. Okay. Perform an in-map scan. So let's take a look at what we got before and see if our answer is there at all. It asked for the 8080. It's saying version. So it's not really saying much else after that. Net BIOS, net user. So let's take the hint. Why not? SV. Check the result under sudo. Okay. So sudo nmap -sv. We did that previously. 10.129.42.254. See if there's a difference here. And version, it's not giving an exact number, so maybe it's just this, or it needs Apache Tomcat 9. Okay, so it's technically it is the version. There's no number, but it works. So let's go ahead and stop here for today. Once again, my name is Sleeper, and that's a wrap. Until next time. Hello, hackers. In addition to your learning through Hack the Box Academy, HackTheBox.com offers additional machines and challenges to test your skills. Like I mentioned, it is a separate account from the Academy side with different plans available. You can sign up with the second link below. I recommend the annual VIP Plus plan that gives you access to all the retired machines, which can help you prepare for the CPTS, PNPT, or OSCP. It also offers your own personal instance for boxes and unlimited time with the Pwn box, which is the in-browser attacker machine. It's what I use for these videos, and it's so convenient. Other than that, good luck on your journey into information security, and here are some more videos to choose from.